Pitch is one of the most fundamental words in all of music. Everything that deals with melody and harmony, scales, and chords starts with pitch. But it is also sometimes misunderstood, and often what we think of as pitch is different to its actual meaning. We might think of a note as sounding higher or lower than another note, but what does that actually mean? So hi there, I'm Mary J. Candelaza. Today I will be going to discuss about pitch format. In this lesson, we'll go through everything there is to know about pitch. But first, what is pitch in music? For this time, I would like you to meet teacher Louise Campbell for her short introduction about understanding musical pitch. So, let's go. Let's watch this.
Hi guys, my name is Alyssa Campbell and welcome to another 2-minute music theory crash course video. Today's topic is going to be on pitch. So in a nutshell, pitch is how high or how low a specific note sounds to the human ear. Pitch is the frequency of vibrations as they go through a sound wave. So if the vibrations are faster, you're going to get a higher pitch. It's going to sound higher to your ear. If you have vibrations that are slower, it's going to sound lower to your ear. So we can take those vibrations and measure them exactly to how many times they go back and forth, and then we can create a definite pitch. So in music, there's actually 12 definite pitches, and 7 of them are named after letters of the alphabet. So you have A, B, C, D, E, F, and G. After G, it starts over again with A, but if you listen as I play this A, it sounds much higher than the A that I played at the beginning. And the reason why is the first A I played had a definite amount of vibrations, and then we doubled that amount of vibrations and we get the higher pitched A. So it keeps the same pitch, but we just doubled the frequency of the vibrations and we get a higher pitch. If we go backwards and work the other way and we divide the amount of vibrations by 2, so here's the first A, the second A will sound lower because we've divided the vibrations by 2. So in a nutshell, pitch is how high or how low a specific sound is to the human ear. And you can take these pitches and put them together in all different types of ways to make different melodies and use them in your songs in a variety of ways. In the next video, I'm going to show you how to write out these pitches on paper so that other people can play your music as well. See you next time.
As what teacher Louise discussed, pitch is a term we use to describe how high or low sounds are. All sounds are caused by vibrations, and when those vibrations occur at fairly consistent frequencies, we perceive them as musical tones. But the biggest question is, what does actually happen when you play a note on an instrument? Whether you pluck a piano key or strum a guitar string or blow into a saxophone, that instrument produces a sound wave. Did you know that the sound wave is just vibrations of air molecules that go back and forth, creating a wave of pressure that travels from the instrument that produces the sound is picked up by our ears? The main property of a sound wave is its frequency, which is just a word for how fast the cycle of the wave is. As what teacher Louise mentioned earlier, that pitch is then how the human ear hears and understands that frequency. This is all a bit technical and mathematical, but just know that pitch is basically the frequency of a note. The higher the frequency, the higher the pitch, and vice versa. The lower the frequency, the lower the pitch. So a note sounds higher or lower than another note if it has a higher or lower frequency than that note. You can easily see on a staff what notes are high pitch and which are lower because they are literally written higher on the staff. Now, here is an example of notes rising in pitch, and here is an example of notes descending in pitch. As you can see, the lower the note is written in a staff, the lower the pitch is. I would like you again to meet Teacher Gerald for his demonstration on how the high and low pitch combined in sound waves using different instruments he prepared.
Hi, I'm Jared. Welcome to Fun Science Demos. And the big idea today is sound and how sound changes. Through science, we've discovered that the faster something vibrates, the higher the sound or pitch. And the slower something vibrates, the lower the sound or pitch. I can show you with my voice. La. My vocal cords are vibrating slower. La. They're speeding up. La. Speeding up. La. They're moving really quickly, so the pitch goes up. I can't show you that through my throat, but I can with these neat little demonstrations. I have rulers fastened to the tabletop. I have a guitar. I have a xylophone. And I'm going to fill a bottle of water to show you that science at work. So let's use these rulers. Again, the slower something vibrates, the lower the sound or the pitch. I can even see that ruler moving slowly. Well, the faster something vibrates, the higher the sound or pitch. Low, high. Slower, faster. Let's check out the guitar. Let's see if we can make that pitch higher by making it vibrate faster. The pitch goes up, the faster it vibrates. Now, let's try the xylophone. You can hear the sound and the pitch go up because that's vibrating much more quickly. This is vibrating slower. Slower, vibrating faster. Now, the water. What's making the sound in there? Well, I'm blowing across the bottle, and the air inside the bottle is vibrating. Slowly. Let's make it vibrate more quickly. I'm going to fill it up with some water. I have some blue food coloring just so you can see it. Now let's try. Oh, you can hear the pitch go up. The sound goes up because that air is vibrating faster. Let's fill it up even higher. See what it sounds like. That air inside is vibrating really quickly, so the pitch is higher. Science is so cool. Don't forget to check out some of our links in our video description. Thanks for watching.
So how pitch is measured? It is measured in hertz. These frequencies correspond in two ways to musical notes. Example, this note is higher than this note. So for better understanding, let's go back from the basic, and that is note. So what is note? A note is a pitch that has a specific name and frequency. Because pitch is a property of sound and not just music, any sound can have a pitch. For example, when you speak, or when I speak rather, my voice has a pitch, but you wouldn't say I am making music. Same when I clap my hands, or clink a fork to a glass of water. I am producing a tone with a pitch, but it is not necessarily a note. Here is a C major scale starting at middle C and going up a full octave. Okay, so now we will be going to identify their measures in every note. So, mathematically, note C and lower can be measured in 261.63 Hz, followed by note D, and can be measured in 293.66 Hz. And then, of course, the note E is measured in 329.63 Hz. Note F is measured in 349.23 Hz. Note G is measured in 392 Hz. Note A is measured in 440 Hz. Note B is measured in 493.88 Hz. And then the last one is the note C and higher were measured in 523.25 Hz. But remember, these notes are all required to be in tune. If the note is out of tune, then it won't meet these frequencies. So, hopefully that it gives you a good overview of what pitch is. In general, pitch is the term for how high and low the note sounds, and it can be measured and written in terms of hertz or notation and a musical stuff. There are a lot of terms and numbers in this lesson, so it could be worth going over a few times to make sure everything makes sense. If you have any questions, let us know in class schedules we have in Mom Bridis, and we'll help you out. Thank you.